So this is the oscilloscope which we assembled recently in my last video, and today we are going to see what all features it has and how we can use it. And it's just a review kind of a video. I haven't finished this setting up on my workbench yet. So let's get started. So first I'll switch it on, and as you can see, once I switch it on, it starts booting. There is a warning, I think, do not help thief report fake. So, okay, so that's kind of a notification something. So now we have the oscilloscope on, switched on, and as you can see, you might have seen in my last video, there is a power jack here to connect the 9 volts power supply, or we can use this connector. But as I don't have both of them, I just soldered the wires to the power pins and I have connected through a regulator to the SMPS on my workbench. So that is the power supply part. And starting with the switches on left hand side, there's a ground, AC and DC switch. So what will happen here is, if your signal has a DC value, say your 3 volts AC signal has a 1 volt DC value, then if you want the DC value to be shown on the oscilloscope, you put it in the extreme right, which is a DC signal. But if you want only the AC signal, that is the 3 volts peak to peak AC signal to be shown, then you'll put it in the AC value. So if you put it in the AC mode, then the DC signal will be chopped down. You won't be able to see the DC signal on the screen. That's the difference between this. And the ground here will ground the signal directly, so it will be a 0 value, and this is used basically to set the level of the signal to 0. Say for example, here I just select the signal and I move it down. If you can see, now I have kept it in the ground, and I'm able to move the mean value or the 0 value of the signal to the bottom and top. So this will help me to set the value to the center, which is this mean line, the x-axis line. Okay, so that is one. The second is the sensitivity. Sensitivity is used to set the voltage peak to peak. Say for example, if you are using a signal which has 20 millivolt peak to peak value, then if you set it at 1 volt, then you won't be able to see the peak to peak value of the signal. But if you have a signal which is 2 volts or 3 volts, then if you set it at 1 volt, then you'll be able to see the peak to peak of the signal. As far as I think, this 1 volt or 0.1 volt or 10 millivolt is the size of each block. So there are almost like 8 blocks vertically, and there are like 3, 4, 5, 6, 12 blocks horizontally. So this will help in that. And next is sensitivity 2 switch. So if you set at 1 volt and if you put this in x1, that is in multiplier, which is 1 into 1, that is 1 volt, then your 1 block size will be 1 volt. But if you put it in x2, that is 2x multiplier, it will set the voltage to 2 volts. Similarly, if you put 5x multiplier, it will give you 5 volts. That is the use of these two switches. These are sensitivity switches just to maintain the level of your peak to peak signal. And these switches are used to select the various parts of the various features of this oscilloscope. I'll show you once I give the signal. So for giving the signal or for testing the signal if it's working or not, you can just correct this red signal. As you can see, even if I touch it, the noise value is shown here. Yeah, so to get a perfect testing, you can just connect it to this test signal, which if you can see here, it's showing 1 kilohertz 3.3 volts peak to peak. So we just connect this here, and as you can see, it shows a square wave. Let's adjust this peak to sensitivity value to give a proper voltage. So one thing is, as you can see, if I keep in DC voltage, the signal shifts up, but when I put it to AC, the signal immediately shifts down. That means that there is some DC component in the signal which has been removed when I put it in AC mode. Now if I keep it in ground, the pin is directly grounded, so the voltage is 0. Now what I'll do is I'll just adjust the level of the signal to, I have to select this one. So just move it to the top. 0. Yes, now I'll put it to AC. As you can see, the level is equal on both the sides of the x-axis, but if I put in DC, the level shifts to the top. So I can say that, signal is completely DC, 0 to 3.3 volts, I'm guessing. If you take 1x, it's set at 1 volt into 1x, that is 1 volt is each block. So 1 to 3 blocks is 3 volts, and a certain part of the fourth block is taken here. So that's almost like 3.3 volts, around 3.3 volts as it is mentioned here. So that's working. If I put it to 2, it shows one block equals to 2 volts, and the other block it's almost like 0.75 or something volts. So that comes to around 3.3 volts again. So I'll set it to 1x and I'll put it to AC signal. So now we have a perfect signal. So what are these switches used for? As you can see, this is a select switch, and if you keep moving this block, each component of this oscilloscope is selected. Now as you can see, currently the time period of the signal is selected, and these two switches are plus and minus, which are used to increase or decrease the value. Say for example, I selected the time period here. I'll press this one, then I'll be increasing the time period. So you can see now decreasing the time period, that's increasing the frequency. So this is 50 microsecond, 20 microsecond, 10 microsecond, so it's decreasing the time period. Okay, if I press the plus button, it reduces the time period. If I press the minus button, it increases the time period. So as you can see, as I press this, the time period increases. Now it's 2 millisecond per block, and that's if you see, okay, this is perfect. So this 0.5 millisecond is 1 block. So that whole thing, 2 blocks is 1 millisecond. That comes to 1 kilohertz, I guess. So that's millisecond. Yeah, so 1 millisecond is 1 kilohertz, and that's what it is designed here for. So 2 blocks is 2 into 0.5 millisecond. That comes to 1 millisecond, and that is the 1 kilohertz signal. So as you can see, if I reduce it more, you can see more signals you can see in the signal, and that is good. So I'll just put it to 0.5 millisecond, that's fine. And next, so if you press the select button again, it goes to auto. So this is synchronization is what I think. So if you select normal, and if you select single, and so every time you press this OK button after selecting single here, so single in the sense it will show single pulse at a time. So unless you press the OK button again, it won't go to the next cycle. So say for example, you have a signal which is sending pulses. So once the pulse come in, it triggers and it shows the signal there, and then if you trigger it again, it will show the next signal. So this is used to analyze the signal more, not just see the whole waveform, but analyzing the signal frame by frame, I can say, then a pulse by pulse. That's what the single thing is used for. Similarly, you have okay, sorry, let me get back. Yeah, so if you press it again, it comes to normal state. Normal state, you have to set the frequency and the state, and if you mostly it's better you go for the auto automatically synchronize the signal and shows you the perfect waveform. Now I'll erase it from hold. Yes, so we can move it to normal, auto, or single. So I'll go to normal, auto, and this here is showing rising edge or falling edge. If you can see, now it's showing falling edge and now it's showing rising edge. So probably it will start from the rising edge, and if you press this again, it starts from the falling edge. So I'm not sure how that will be useful. If you know it, just you can comment it and tell me like how this falling edge or rising edge is useful. Next I'll go for this one. So as you can see, these lines are selected here, and if I press it again, it's selecting this line. So these are used to set the median of the signal and have it in a level equal to the x-axis. So this will be useful for you to analyze the signal, and you can maintain the 0 of the level to the 0 of the axis. Next, it is used to select this bar. Probably this is used to move the signal left and right. As you can see, when I press it, it's moving. Signal is moving to the right. If I press this again, the signal will move to the left. The buttons are quite hard. If I get a chance, I'll replace them with something soft buttons or something, just to have a bigger life and easier, to have a better life and easier operation. This is quite hard to press. Okay, so next comes the frequency again. So yeah, that's what these buttons are used for. One more thing to show you here is this OK button. The specialty of this is, say for example, you're not able to make out the voltage of the signal or the frequency of the signal. So how can you do that? So this has a feature where if you press and hold the OK button for some time, it will automatically show all the details of the signal. So as you can see, the Vmax goes to 1.89, the Vmin goes to minus 1.89. So the total peak to peak is shown here, which is 3.7 volts. Probably this is including the noise ratio, whatever is there. And I'll remove it from the whole here. Yeah, so duty cycle is 50%. So the 50% of the time the cycle will be in on state and the 50% will be in off state. That is 50% is high voltage and 50% is low voltage. So that is this duty cycle. PW, don't exactly remember what the PW means. Okay, let's see that later. If you know, just comment it out. Next is cycle. Cycle is the time period of the signal, which is 1 millisecond. So from one fall to the rise, and it equals to 1 millisecond. And the frequency next is 1 kilohertz, as you can see, and it is meant to be 1 kilohertz, which is expected. So those are the things. I'll remove this one now by pressing it again. It will go away. So those are the features of this. So there's a reset button here. So what can you do with this is, every time your CRO gets bricked or it stops, it's hung, it's not working anymore, just press the reset button. So what it'll do is it'll reboot the system again. It'll start from the first. So as you can see, it's rebooting and we'll get a notification, yes, and then again it will go to the CRO screen. There you go. So it's reset completely and it's working fine. And as you can see, there's an LED here. This tells you that your CRO is alive and it's not not dead. If it's blinking, that means your CRO is working and operating fine. And if possible, I would give it a small case. If possible, I'm not sure. I heard that there were case already available for these CROs in Amazon and other stuff. So you can get them from them if you feel uncomfortable operating this like this. And there are a few more pins here, header pins. One says point. So header pins here saying plus 3.3 volts. DO, I don't know what that means. Clock, ground. There's one more ground here and receiver transmitter pins. So I haven't explored this more. Probably if I get some time, I'll go through the features. And there's also a USB pin here. I am not sure how that can be used, and even it's not mentioned in the catalog which comes with this one. But it said that it can be used to program the board more, or if you want to change the program of the board, you can use this one. But I don't think, I don't see a need why I would like to play with the firmware of this thing, just in case I spoil that. So these things are the features of this board. Let me know what you feel about this one, and I feel that this is a good one, just at least for a starter. It may not have all the features which actual CRO or the big ones which you get do, but yes, for a basic piece, to learn how it works and for analyzing small signals, this is a very good piece. I would prefer this, and I would advise you buy. So this piece is not sponsored by anyone. I bought it and I used it. I feel it's good, so I'm telling you. So it's nowhere sponsored by anyone. So that's all for today's video. If you like this video, you might like some of my other videos too. If you haven't checked out my construction video, just go to that video and check it out. I'll put the link in the description. And that's all for today. Thank you, and I'll see you in my next video. Bye.